Which brings us to solving equations here now, all right? The key here, when we're solving these equations, if it's an exponential equation, if we can write it with the same base, then that works pretty nice, all right? Here we have 2 to the 4x minus 2, and so we have 64. So we ask ourselves, is that 2 to some power? And if you go through your powers, it is. It's 2 to the 6th power. So since we can write that as 2 to the 6th power, that means these exponents have to be the same. So 4x minus 2 has to be equal to 6. And now, just looking at the powers there, that is a fairly straightforward equation to solve. Add 2 to both sides and divide by 4. X is 2. That's the key. Here we have 25 to the y equals 625. And so, well, 625 is 25 squared. So we can write it with the same base. So y is 2. That's the idea there. Okay. This is, again, is if we can write it with the same base. Now, here we have 9 to the x plus 3, but this is not a power of 9. But if we think about it, this is a power of 3. And 9 is a power of 3. 9 is 3 squared, right? So we can write this as 3 squared to the x plus 3. Now we have bases of 3. We might rewrite this one more time because power to power multiplies. So this is 3 times x plus 3 equals 3 to the 3rd. And so these two things have to be equal to each of these two exponents. Now that we've written it with the same base, we can say 3 times x plus 3 has to be equal to 3. A whole lot of 3's going on there. Okay, so now maybe distribute here. 3x plus 9 equals 3. Subtract 9 from both sides. All right, divide by 3. And we have negative 2. Okay, so again, if their powers are the same base, we can write them as the same base, and then just make the exponents equal to each other. Now, if that doesn't work, then we're going to need a new method, and this is where our logarithms come in. So solving exponential equations using logarithms. This will be our most general method. Okay, so here's what we want to do. Here's some steps. We've got an equation with an x in the exponent. That makes it exponential. So what we need to do is isolate the exponential. Let's get that 4 out of there. Okay, and we've got 26 on the right and 5 to the x minus plus 1. Okay, now there's lots of ways to think about this, but we're going to try to avoid properties. If you go look online, you'll find a bunch of videos with different properties, but this is the most simple way to go for now here. So now we're going to change this to an equivalent logarithmic equation. Remember, if we have b to the y equal to x, then we can swing that base around, and this means that y is equal to log base b of x. So these two things are interchangeable. That's kind of key property there. Okay, so what we need to do is we need to take our base here, and we're going to swing it around. We're going to write this as a logarithm. So we can say x plus 1 is log base 5 of 26. Well, there we have it. Now we just need to subtract 1. Log base 5 of 26, we don't know that, so I'm going to leave it alone for right now. Okay, so we subtract 1 now, solve. Okay, log base 5 of 26. There is the exact answer. Okay, that is an irrational number. Okay, now, whoops, I forgot my minus 1, huh? Let's get that minus 1 in there. Don't know where that went. Okay, so the 26 is in the log, but the 1 is not. So that's the exact answer. If we want to get an approximate answer, well, we can take log of 26 and divide it by log of 5. And then we'll subtract 1. And this will give us a decimal answer here. Again, this is exact because it's written without rounding decimals off there. But if we go to our calculator again here, log of 26 divided by log of 5. So miscellaneous log of 26, close the parenthesis, 6 divided by the log of 5. Whoops, I didn't get my divided in there. Close the parenthesis, divided by the log of 5. There it is, 2.024. Okay, so x is approximately 2.024. So that's how it works. We change it to a logarithm, and then we use the change of base. We can find the exact answer, then we can use the change of base if we want an approximate answer. So let's try that same step to find the exact answer of these and then the approximate answer. Okay, so don't change it yet. You want to get that exponential all by itself. That 4 to the x in this case, so divide the 3 off. 4 to the x equals 25. Now we want to change it to a logarithm. Okay, we're using the definition of a logarithm. This is the log base 4 of 25, which we can find out as the natural log of 25 divided by the natural log of 4. And that's the exact answer. We could use a common log too. If we want the decimal, so we'll go log of 25 divided by log of 4. So we got the natural log of 25. And then we're going to divide by the natural log of 4. And there it is. 2.322 is good. Okay. 2.322. So x is approximately 2.322. So again, we have an exact answer here with the logs, and an approximate answer with just the decimals there. What about base e? Well, let's get that e to the 2x all by itself. We've got to get the other stuff out of there. Add 4. So 30 equals 10 e to the 2x. Okay, don't go final log yet. This is 10 times, so let's divide by 10. And so now e to the 2x equals 3. Now we can change it to an exponential form. So let's slide that e over there. It's an E, it looks more like an L. I've got to be careful. There it is, okay. So this is going to be 2x equals log base e of 3, but we don't like to write log base e that way, right? We want to write it as the natural log. Okay, so we're swinging the base around, and we get the natural log of 3. To finish this off, we're going to divide by 2. Okay, so x is just the natural log of 3 divided by 2. That is the exact answer. Okay, now if we go to our calculator, natural log of 3 divided by 2. Let's try that out. Natural log of 3, close the parenthesis, divided by 2. And we got 0.549, it looks like. Okay, so this is approximately 0.549. Okay. All right, one more here. Bring the calculator on over. Again, we want to get that exponential all by itself, so let's get that 4 out of there first. So 10 to the x plus 1 equals 24. So now we're all ready to change it into exponential, or into logarithmic form. So the exponent, which is x plus 1, equals log base 10, which remember when it's base 10, we don't usually write the base 10, so it's the log of 24. Subtract 1 from both sides. X is log 24 minus 1. By the way, if it's written this way, notice there's no parentheses over here. Well, only the thing that's attached to it is in the logarithm. This is outside. Okay, if you want to put parentheses around here, you can. There's the exact answer. And if we wanted to get a decimal, we can go our calculator. It's just log of, what do we say? Log of 24 minus 1, all right? So log of 24 minus 1. And that gives us 0.380. Okay, so 0.380 is our final answer. 0.380. X is approximately that. All right, so again, the exact has a logarithm in it. In the approximate, it has a decimal. All right, so that's the idea. Again, get the exponential all by itself, then change the exponential function into a log function, and you're good to go from there.